Okay, it's Mrs. Boots again. It's time for our exponential functions. Now, exponential exponents. We kind of remember this a little bit, but where do we see them in real life? Well, there's some cool parts and not some cool parts, right? We see exponential function in bacteria. Ugh. Okay, so bacteria. Remember in the morning, you're sitting there and maybe you have a little bit of a sore throat and then by that afternoon, you've got a fever, you're feeling horrible, and you go to the doctor. Bacteria multiplies at an exponential rate. So yeah, we're interested in modeling that because guess what? Medicine is also a exponential, and that combats our bacteria. And then I know you'll love this one. We'll just call it money. It's investments. Investments. Now also loans. Loans deal with exponentials and investing things is exponential. And so when we get into the exponential unit, we will do bacteria, medicine, and money in exploring some examples of that. Our parent function, we can have multiple bases. I want you to look at this. We're going to use 2 to the x. I could use 3 to the x. I could use 4 to the x. I could even use 1/2 to the x. But we're going to use 2 to the x. And that's simply so we have small numbers, okay? Nothing really big there. It's easier to graph, okay? So we may be sitting here thinking, how do you take a -2 power? When I plug it in, I got to plug in a -2, right? So you can use your calculator or you can take my word for it because you may not remember negative exponent moves it to the bottom. So it's actually 1/4. Okay, we're going to square the 2 and put it on the denominator. Here, this would be 2 to the -1 power, which is 1/2. 2 to the 0 is not 0. It's 1. We have another function that doesn't have 0, 0. It started with that crazy rational, but exponential does the same thing. 2 to the first power is 2. 2 squared, easy enough, 4. Now let's put this on the graph. So at -2, we're at 1/4. That's kind of crazy to put on the graph, so we're just going to put a little smudge of a dot right there. Okay? At -1, we're at 1/2. That smudge is a little bit higher. At 0, it's at 1. At 1, it's at 2. And at 2, we're at 4, which is, oh, put that in the wrong spot. Right up there. Okay? So if you look, it's going up and to the right. You may remember this from Algebra 1. They did basic exponential curves. This would be an exponential growth because the 2 is bigger than 1. So we're growing. It's going up and to the right. But guess what? It's never going to touch 0. We have yet another function that has an asymptote. Okay, so my x values never touch the 0. I'm sorry, my y values never touch that x-axis there. Doesn't matter how big that negative number gets, it's just going to be a super small fraction, okay? But that's okay, we can handle it. So let's look at this. Domain. How far to the left does it go? All the way to -infinity. Super easy. We've done that before. How far to the right does it go? Well, it's going up, but it's also going to the right. So we're going to positive infinity. Easy. We know this one. We've done that, right? Linear, quadratic, cubic, cube root. All of those. Infinity, infinity. Absolute value does that too. The range is where it gets a little tricky, right? It doesn't go to -infinity. We don't have anything down here negative. It starts kind of at 0, but we just said it doesn't touch 0. Remember how we indicate that is going to be a parenthesis. We're going to put a parenthesis with that 0. And then how high does it go? It goes to infinity. So we're going to go from 0 to infinity. Wouldn't it be great if we could invest our money and get to infinity? We'd be really wealthy. I'd be happy with $1 billion or $1 trillion personally, but infinity is not bad if we have to go there. So we're going to look at that when we get to our exponential functions in our exponential unit. And this ends our exponential parent function.